Hello, my name is Sparsh Koushik, and today I'll be discussing out-of-order execution using Tomasulo's algorithm. Let us first consider why do we need out-of-order execution. Let's take this example of instructions. If we consider I0 and I1, we observe that there is an actual data dependency present here, a true data dependency, because the output of instruction I0 is an input for the instruction I1. If this were an in-order execution processor, the processing would stall at I1 instruction. On the other hand, if we had out-of-order execution, the instruction I0 could have been executed in parallel with the instructions I2 through I6. This parallel execution would result in better performance, and hence out-of-order execution is desirable. Let us now consider the Tomasulo's algorithm for out-of-order execution. This block diagram represents the Tomasulo's algorithm. Let us go through the different components of the algorithm. The first component is the instruction queue. The instruction queue holds the instructions to be executed and issues the instructions to the next component, that is, the reservation stations. The reservation stations are of certain types. They can be either for adder or subtractor, or they could be for multiplier divider, depending on the algorithm. The next component would be the RAT and the registers. The RAT or register aliasing table is present to remove false dependencies using register renaming. The registers will hold the values for the registers and would be updated by the output after the operation is completed. The store buffer and the load buffer will be used to access and write data into the memory. The Tomasulo's algorithm will have three major steps: the fetch or the issue stage, the dispatch stage, and the broadcast or the write back stage. The issue is given by the instruction queue to the reservation station, and the reservation station waits for all the inputs for that instruction to be available and then dispatches the instruction to the ALU. In this case, the ALU computes the data and then write back the instruction on the bus from where it is picked up by the register and the RAT for updating. This broadcasted value is also picked up by the reservation stations who are waiting for one of their inputs to be available. Let us understand this further using an example. Let us take this instruction I1 and I2. The I1 instruction is an add instruction, and we can issue this instruction straight away because the reservation station is empty. So issuing the add instruction, we have the two inputs R2 and R3. So before filling in the inputs or for this instruction, we must check the RAT. We observe that the RAT for R2 and R3 are empty. So the value for R2 and R3 are present in the original register. The value of 15 and 20 are applicable here. Similarly, the output for this add instruction is written into R1. So we shall update the RAT of R1 to point to reservation station 1, i.e., when the reservation station 1 finishes its computation, the value should be updated for R1. The next instruction, I2, can also be issued because the reservation station is empty and available. For this, the output is to be stored in R4. So R4, the RAT for R4 shall be updated with RS2. The two inputs for the subtract instruction are R1 and R3. We need to check the RAT for the values of these first. For the R1, we observe from the RAT that the instruction of RS1 shall be used because this value depends on the output of the reservation station 1. The R3 entry for the RAT is empty, so the R3 contains the original value from the register, which at present is the value of 20. So this finishes the issue stage because the instructions from the IQ have been issued to the reservation station. The next stage is the dispatch stage. In the dispatch stage, we'll check which instructions have all their inputs available. In this case, the RS1 has its inputs available, the R2 and R3, which is 15 and 20. So RS1 can be computed, can be dispatched to the add unit, and the add unit computes the data and puts the data on the bus to be broadcasted. The data of 35 along with the tag of RS1 is dispatched. This dispatch data is taken by the reg to update the value of RS1. And this data is also taken by the rat to update the entry for R1. Because the data for R1 is now present in the reg, the latest data is present in the reg, we can clear the rat to point that the correct data is available in the register. This finishes the execution of instruction I1. This RS1 is also broadcasted to the reservation station 2. And because reservations 2 was waiting on RS1, now all the inputs for RS2 are available. So now the RS2 can also be dispatched and then broadcasted on the common bus. That's all I have for today. Thank you.